Hello everyone, I am Rajan Singh. I am a PhD student in EEE department of IIT Guwahati. I am working under Professor Roy P. Pehli. Today we are going to demonstrate photolithography process. So this is a clean silicon wafer, silicon dioxide wafer, approximately 500 micron thick and 20 nanometer of silicon dioxide deposited grown over it. So this is pre-cleaned via RCA cleaning, and now it is over the hot plate for removing any moisture. So you can see approximately 135 degrees Celsius we have kept around 10 minutes. So whatever water vapors are present, water humidity present, it will remove. Then we will go to this instrument, which is a spin coater. So you can see this is a chuck in which this wafer is going to sit. Then these are the vacuum pumps. So the pipe is connected in the back and the suction will come on the top. So vacuum will suck the wafer on its place and this chuck will rotate. The rotation speed and the time we can vary over this panel over here. So we will place the wafer over it. We will put the photoresist and then spin coat it. After that we will dry it again with this hot plate, and then we will go to mask writer, which is this machine for direct exposure, or this UV box in which we will do the exposure with the help of a mask. So we will show all these steps one by one. So first, so the preheat is over. So 10 minutes preheating of this wafer is over. Now we will keep this wafer to cool it down little bit, and then we will follow by HMDS coating, and then we will proceed for photoresist coating. So now we are going to keep this wafer on this chuck, and we have to make sure that it sits properly over the chuck so that no disbalance will happen during the rotation. Now I will on the vacuum. So the vacuum will hold this wafer over the chuck. Now we are going to put the HMDS over the wafer. Only slight is enough, and then we will load the program and close this chamber so that nothing will come out. So you can see we are going to rotate about 4000 rpm for the acceleration of 5, and then time is 60. So now the HMDS coating is over. We will take the wafer out. We will switch off the vacuum first, and then we will slowly take it out the wafer and keep it over this hot plate for heating up. So it will be 135 degrees Celsius for about 5 minutes. So about 2 minutes left. So we are going to deposit photoresist after this. So there are two types of photoresist. That's 1813, which is positive photoresist, and SU8, which is a negative photoresist. So we are going to demonstrate with S1813. And we are lifting this wafer from the hot plate and keeping it to cool down till the room temperature. After that, we are going to take the S1813 bottle from the fridge, and then we will repeat the spin coating process for positive photoresist. So now the photoresist spin coating is over. I'm switching off the vacuum and take it out of this wafer. and keep it for heating for 3 minutes at 120 degrees Celsius. So now the heating part is over. Photoresist is dried now, and you can see it is kept to cool down at a room temperature. You can see a slight reddish color over the surface, which is obviously because of photoresist. Now we are going to use lithography machines. There are 3 machines, 1, 2 and 3. So we can do the lithography with this machine, which is called a mask writer. As you can see, inside this machine a laser source is there and then optical system is there. So the laser will fall from this head to this chuck. Here we can keep our mask or even the coated wafer, spin coated wafers, for direct writing. So the laser spot size is about 2 micron and it will travel 10, 20, sometimes 1 mm per second speed. So the desired energy as well as the speed is selected as per the features which you want, and then the lithography can be performed. But this is a very slow process as the laser has to travel all the feature one by one, and therefore a lot of time is consumed. So in order to save the time, what we can do, we can use the mask, write the mask one time and then use this UV box for the exposure. So our photoresist is sensitive to this UV radiation. So the UV radiation will fall and the patterns will appear over the silicon wafer. So this is the wafer. So this is the mask which I was talking about. This is a soda lime glass over which chromium coating is there, followed by the photoresist coating. So we can write the designs directly with this machine, develop it, etch the chromium, and you can see the final designs will appear like.
So there are many type of designs. So like there are some saw designs, some micro channel designs, and some designs which you will not be able to see are basically FET and chem register type of devices.
So you can see there are some markings. So we have to keep our wafer so that it will fit in between these markings. I am going to put the mask very carefully. The loading is complete. It is asking what is the thickness of the wafer. So it is 500 micron. Now masking distance. So for better development and fine features, we go for hard contact, or that's why the distance is 0. Now it is adjusting the distance between the mask and the wafer. So now loading is done, distance adjustment is done. So we move towards the next step. So I'm going to do a continuous exposure. So duration will be 4 seconds. And power is 25%. So these values are already optimized. Now the exposure is being performed. Now the exposure is finished. I will take it out one by one. Very slowly. So I am going to develop the patterns. So in this petri dish, the developer solution is kept, and in this one, the DI water is kept. The developer solution will expose over the surface for about 10 seconds, 10 to 20 seconds. So now I am going to dip this wafer very slowly and start the timer, and very gently shaking this. So I have developed it and then wash it with DI water, then again dry it using nitrogen. Now you can see the patterns appear over the surface. Roughly you can see there are some shiny things appeared. Examine these patterns, the distance and everything using the optical microscope.
If the pattern and their distances are up to the mark, then we can move towards the next step, which is metallization and lift off.